This 6.2. Let's do more complicated questions. Suppose, for example, I do, did I do number 4, by the way? Okay, cotangent alpha equals to negative 1 over radical 3. So the thing is, I don't memorize the value for cotangent. Let me make it tangent, which is the reciprocal. Therefore, on the right-hand side, I do the reciprocal also. Now, and then tangent what equals to radical 3 in quadrant 1. Quadrant 1. We see that's 60 degrees, right? But I have to answer that in radian. Now, then going back here, then alpha equals to, let me use the one in quadrant 2, 2 pi over 3. Okay. Now, don't forget that this is actually will act as a reference angle. Reference angle for alpha, and the alpha that I look for is in quadrant 2. However, we also know that tangent has a period of pi, so I will add integer multiple of pi. Okay, sometimes I use lowercase n, sometimes I use lowercase k for integer multiple of something. Now, let me continue a bit with a follow-up question. Now, suppose in part A here, the question is find all solutions. Find all solutions. And that's what we get. Now, suppose then they ask this question, find the solution in the first period from 0 to 2 pi. Then we continue from that, the general solution, we continue from there. And then you said when n equals to 0, what happened to alpha? When n equals to 1, what happened to alpha? When n equals to 1, I think we'll get 5 pi over 3. Okay. Now, of course, you may wonder, Thomas, how far do we need to go with the n? Well, just go as far as you get something in that interval. So suppose I don't know when to stop. I go on further when n equals to 2, then I will get alpha equals to 8 pi over 3. But this is already more than 2 pi. That's why I will cross it out. Okay? That's why I will then cross this out. Okay, so the general solution that's if they ask for all solutions. The general solution will be alpha equals to 2 pi over 3 plus integer multiple of pi. And if they want to have from 0 to 2 pi, then alpha will be 2 pi over 3, alpha equals to 5 pi over 3. Okay, that's for number 4. Let's try, for example, number 6. I will try to do more problems in this section, but at the same time, I don't think I can have time to solve all the possible problems here. So later on, I will ask you to pick some questions that you want me to work on. Okay. Number 6, cosecant gamma equals to radical 2. Again, I don't memorize cosecant. Let me change to the reciprocal. That's sine gamma equals to 1 over radical 2. Now, gamma is positive, sine is positive in 2 quadrant, in quadrant 1 and quadrant 2. In quadrant 1, the one that gives us 1 over radical 2 is 45 degrees. In quadrant 2, the one that gives me 1 over radical 2 is 3 pi over 4. Okay, now then don't forget, I need the general solution, right? So I will say plus 2 pi n plus 2 pi n. That's the general solution. Now, suppose the actual question is find the solution in the interval from 0 to 2 pi. Then you play with the n. When n equals to 0, what happened to the gamma? Gamma is pi over 4. Gamma is 3 pi over 4. When n equals to 1, gamma is more than 2 pi for both of them. That's why then I will cross it out. Okay? So if the question only asks for general solution, and we say gamma is pi over 4. Gamma equals to 3 pi over 4 plus 2 pi n. Oh, by the way, if you want to write two different answers on the top of each other, you're supposed to use these braces here. Without this braces, you are saying that the first line here, implies the second line, as if there's only one answer. Okay, that the first one implies the second one, but that's not what we are trying to say. We are trying to say that there are two branches of solutions, and because of that, we will write it using braces. Okay, now that means there are two solutions. Okay, now if we want the 0 to 2 pi solution, then we will say, oh, gamma equals to pi over 4, gamma equals to 3 pi. Okay, let's do more. I will start working on harder problem. For example, number 12. Find all the solutions for 2 sine 3 theta plus radical 2 equals 0. So I subtract by radical 2 divided by 2. That's negative radical 2 over 2. Okay, now the way we solve this Thomas, what happened? I have that 3 theta. Don't worry. We look at that 3 theta as one angle for now. Okay, so that 3 theta will have that value at two different angles. 3 theta equals to, the reference angle is 45 degrees, pi over 4. Now it is negative in quadrant 2 and quadrant 3. I'm sorry, quadrant 3 and quadrant 4. So in quadrant 3, that will be 5 pi over 4. In quadrant 4, that will be 7 pi over 4. Okay, now don't forget, then I will add 2 pi in. Oh no, did I get that right up there? Yeah, okay. And the because the period of sine is 2 pi, right? 2 pi n. Now, and then after we solve for the angle, then we solve for the theta. Okay, divide by 3. See, theta equals to 5 pi over 12 plus 2 pi over n. Theta equals 7 pi over 12 plus 2 pi over 3n. Okay. Now, actually, if you want to make your life even easier, we are done. Actually, we are done here. We are done here. That's for the general solution. Now, suppose I change the question to find all the solutions in 0 degrees to 360 degrees. Okay, now then we continue from the general solution. Okay, we continue from the general solution. Theta equals to that's 5 pi 3 theta equals to 225 degrees plus 360 degrees and 3 theta equals to 315 degrees plus 360 degrees and now I get that from here. Okay, I get that from the and so I basically reinstate that in degrees and then I divide by 3. Right, when I divide by 3, I get 75 degrees plus 120 and theta equals to 105 degrees plus 120 degrees. And now then we will work with the n to put these angles into 0 to 360 degrees. So when n equals to 0, that's easy. Theta equals to 75 degrees. Theta equals to 105 degrees. When n equals 1, theta equals to 195 degrees. Theta equals to 225 degrees. When n equals to 2, theta equals to 240, 315 degrees. Theta equals to 240, 345 degrees. And when you try n equals to 3, there will be more than 306 degrees already. Okay, so then we know that we will stop. We'll stop at n equals to 2. Okay, you will see that for sine, cosine, if the angle is 3, then your n will be 0, 1, 2. If the angle is 2, is 0, 1. If the angle is 1, then n equals to 0. That's for sine, cosine, sine and cosine only, and of course secant, cosecant also. Okay, so if the coefficient here is 5, okay, up to like that. Okay, now let me list the solution first. So solution in 0 degrees to 360 degrees are 75 degrees, 105 degrees, 225 degrees, 315 degrees, 345. Okay. Now, using the same idea, let me ask you to try number 14. Number 14, cosine 1/4 x equals to negative radical 2 over 2. Okay, get this just the general solution. Just to get the general solution. And if possible, number 16 too. Number 16, cosine again. Cosine of x minus pi over 3 is -1. Okay, so what you will do, you will solve for x minus pi over 3 as an angle first. Okay. Let me give you maybe like 3 minutes for this. Just get the general solution. Okay, let's start. This guy here is cosine is negative in quadrant 2 and quadrant 3. So let me move a bit to the left. So 1 for x, reference angle pi over 4, but in quadrant 2 pi over, in quadrant 3 that pi of x will be 5 pi over 4 plus 2 pi x. And then to continue, I will multiply both sides by 4. I will get x equals to 3 pi plus 8 pi n. X equals to 5 pi plus 8 pi n. Okay, now that's the general solutions. Now, strangely, if we want to see solution in the first period from 0 to 2 pi, you will see no solution in the first period, right? Because when n equals to 0, it's already 3 pi, right? When n is -1, it's -5 pi and -3 pi. Still not in this first period here, the first interval. Okay, go on. Cosine give you -1 when angle is high.
Hey, Professor.
Yes.
How come for 14, how come we don't multiply both sides by 4? Because it's already a fraction.
Why do we don't multiply by what?
By 4?
I did. Actually, 3 pi over 4, when you multiply by 4, it becomes 3.
Oh, yeah, my bad. Sorry.
Right?
Yeah.
Yeah, well, good observation.
I made a mistake, sorry.
And then coming back here, and the period for cosine is 2 pi n. By the way, for sine and cosine, if you remember, cosine, it reached the +1 only at 0 and 2 pi multiple of that. To reach -1, it happens only at pi. Okay, now it's different from other numbers in between, in which you may have two angles reaching those that value. Okay, but for -1, it happens only at one place. Okay, so that's why we have only one branching here. Now let me continue. So x equals pi over 3 plus 2 pi n. That's the general solution. Okay, if I need the particular solution from 0 to 2 pi, then again you play with the n. Okay, so of these many questions that I have done here, how many questions? I have done 5 questions just for today. I want you to realize that when we need the particular solution, we get the general solution first and then play with the n from there. Find this question 16. Let me modify that. I have colors, so I can play with the colors. Suppose I have 3x here. So again, I x, and then from there I divide by 3. So I get x equals to, maybe I use another color, not the same color. Let me use red instead. So x will be 4 pi over 9 plus 2 pi over 3n. Okay, if we have that 3 there, if we have this 3 here.
I'm sorry, Thomas. Can you just go over how you got to the pi plus 2 pi n again?
Pi plus 2 pi. Oh, cosine theta is -1. Cosine theta is -1 when theta equals to pi.
Okay, perfect.
Right?
I got it.
Now then
Thank you.
I add the period to pi n.
That's right. Okay, thank you.
Maybe I put a note here. Okay. Now then, let me go on to a more complicated question. So far we are fine. I hope. Number 26, or how about number 28? I think that's better. Number 28. Number 28. 3 minus tangent squared beta equals to 0. So I solve for tangent squared beta, that's equals to 3. Then tangent beta will be plus minus square root of 3. Okay, now what I want you to do, I want you to solve each branch separately. I hope that explains why in the past I always want you to separate them if you have that plus minus sign like that. Because leaving them condensed like this, if you have that habit, then you may not know how to proceed from there. But then after you split them, then you know what to do. Okay, now let me ask you to solve this here. Solve for the beta and solve for the beta here. Okay, and later on I will show you some additional steps. Let me give you 1 minute for that. I need to check my internet. It says a couple times that my internet's not stable.
Is it pi over 6?
That's pi. I don't think so.
No? Then it's 5 over 3.
Yes. Pi over 6 will give you 1 over radical 3. Okay, so this is pi over 3. And this one is 2 pi over 3.
Over
Is it
3.
right?
Yes.
Now then, don't forget that we need to add the period. Plus pi n. Plus pi n. Okay? Number 30. Very similar question. Number 30. Very similar question. 4 sine squared x minus 3 equals to 0. Now let me ask you to solve that. You will have 4 branches later on. So you will have 2 branches for the plus minus. Right? You will have 2 branches from here. Okay, when it is plus, when it is minus. And for each, for the plus 1, we have 2 branches, quadrant 1 and quadrant 2. And for the negative 1, we have quadrant 3 and quadrant 4 solutions. Okay, work it out. This one, I give you 3 minutes at least. Okay, let's work it out. So sine squared x equals to 3, 4. So sine x will be plus minus square root of 3 over 2. Now I break it up. Sine x is radical 3 over 2. Sine x is negative radical 3 over 2. So x will be pi over 3 plus 2 pi n. X equals to 2 pi over 3 plus 2 pi n. While for this branch here, x equals to 4 pi over 3 plus 2 pi n. X equals to 5 pi over 3 plus 2 pi n. Okay, now if you get this answer, then you are fine. However, I want to show you something I call condensation.
Excuse me, Professor. I can't actually see the rest of the equation. Can you shift over to the right, maybe? It's cutting off on.
Oh, like this?
Yes. Yes.
Oh, okay. Yeah.
Thank you.
So what on my screen I can see it, but not on your screen, huh?
No.
Oh, okay. Well, let me know in future. Okay, let me know. This is first time I found out. Okay. Let me continue. I want to show you what I call condensation. Now, what happened is for this branch here, the angle is 60 degrees here, right? Okay, that's the pi over 3 plus 2 pi plus 2 pi plus 2 pi. Now, compare that with this branch here. Compare that with this branch here. That branch is 4 pi over 3 plus 2 pi plus 2 pi plus 2 pi. Now, what I will do, I will condense these two yellow one here, so the red and the blue, I will condense them together, and I will write them as x equals to pi over 3 plus pi n. Okay, now how do you explain that, Thomas? Now the first one here, the red one here, it's pi over 3 and then plus 2 pi plus 2 pi plus 2 pi. You keep on getting red, right? While the blue one, 4 pi over 3, you will get the blue and then plus 2 pi, there's another blue, there's another blue, there's another blue, every time you add 2 pi. Now, if I rewrite it this way, okay, then I start from pi over 3, and then 4 pi over 3, and then 7 pi over 3, and then 10 pi over 3. So it's kind of like as the n move, at the end, when n equals 0, it's red, and then blue, and then red, and then blue, and then red, and then blue. You see? So I can condense these two solutions into using these notations here. Instead of writing 4 solutions, I will write only 2. Now you can see the one here, and this guy, I can condense that too. I can condense that to be the 2 pi over 3, okay, and 5 pi over 3, okay. This is the 2 pi over 3, and this is the 5 pi over 3. Now, when I condense them, then I will get x equals to 2 pi over 3 plus pi n, not 2 pi n, plus pi n. Okay, now, so notice that from here, if I add pi, when I add pi, I will get this. When I get another pi, I get that, and alternating. Okay, so so you will see if you have 4 solutions that you have on the top. If you write your solution this way, if you write your solution, if you write your solution as x equals to pi over 3 plus 2 pi n, x equals to 2 pi over 3 plus 2 pi n, x equals to 4 pi over 3 plus 2 pi n. x equals pi over 3 plus 2 pi n. I will fully accept that. However, when you compare with your book, at the back of your book, you may see the condensed version, pi over 3 plus pi n, and x equals to 2 pi over 3 plus pi n. Okay, so this answer here is okay. This is okay. This is okay. But the one you see in your textbook very likely is this one. And this is textbook.
Hey, Thomas.
Yes, huh?
How come in number 28 then is the answer pi over 3 plus pi n and not pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n?
Because for tangent, the period is pi. For tangent, the period is pi. The period.
Oh, like when you graph tangent, the period is pi. That's right.
That's right. So the period for sine and cosine is 2 pi. And of course, consequently, secant, cosecant also, right?
Right. And then tangent, cotangent is just pi.
That's right. Mm-hmm.
That's right. Okay, I remember now.
Tangent and cotangent is pi. Oh, don't worry. You may ask me that question again, and I will answer you the same way again. The reason I say that, because when I learn it myself, I have the same question again and again. Say, why 2 pi? Why pi? Why 2 pi? Why pi? Okay, and I have to repeat that again and again and again to remember, to keep myself. And the thing is like, once I get into, so your what happened? What your sentence is exactly the same to the sentence I have. Okay. Once my teacher, I remember very well. Once my teacher talked about this condensation, I suddenly just like, why is now becomes pi and the tangent also pi, you know, okay? But the reason is mainly because what we did here in number 30, we have condensation, okay? In number 28, no condensation. So it is possible there could be a question like for example, I think that's one question I saw there. I just make up the question then. I don't remember which instead. So for example, tangent squared theta equals to 1. Now, if I solve this, I get tangent theta equals to plus minus 1. Is it right? For tangent theta equals to 1, I get theta equals to pi over 4 plus pi n. But for tangent theta equals to negative 1, the theta is 3 pi over 4 plus pi n. Now, the thing is, if I try to sketch that, if I try to sketch that, then pi over 4 plus pi will give me this, while 3 pi over 4 will give me this. Okay, now notice that I can actually condense them. I can actually condense them to be theta equals to pi over 4 plus 90 degrees, multiple of 90 degrees. You see what I mean? So even for tangent, there are situations that we may be able to do condensation. Okay, yeah. But in your case, for now, my assumption is this is the first time you learn trigonometry this deep. At West LA College, the requirement for them to take Precalculus is trigonometry. So at my West LA College, once I get through trigonometry part, I can go a lot faster. Okay, you know that I post this on YouTube, right? I said this many times. So you can compare when you go to YouTube and you see my lecture when it comes to trigonometry. My lecture for them is different from the way I present it to you, even though both your classes are Precalculus. Let me show it to you. It seems like they are slightly behind schedule originally. You are at my browser, right? And let me go to YouTube. Then this is your Precalculus. Are you with me, everybody? Are you seeing my browser right now?
Yeah, we can see it.
Yeah,
we can
okay.
see it.
So yours is here, right? Okay. My Precalculus class is here. Okay. Now most of the material, especially for the algebra part, they are the same. Yours are the same. But once you get into trigonometry, the way I discuss it with you is more detailed compared to the way I discuss it with them, because I assume they know most of that already. Okay. So you will see the way, if you want to see harder problems, actually compared to yours, slightly harder examples, then you may see it from their class. Okay, even though when it comes to tests, very likely I just use the same test. In other words, for you, I need to bring you up to Precalculus level. For them, they are already at quote unquote a little bit more than Precalculus level for their trigonometry. Okay, now, but I want to say this though. After this section, I would need to do some formulas that you need to memorize. And I strongly suggest you to watch some of my lecture video from my trigonometry class at West LA College. Let me click for you. And the one I want you to watch, the one that I want you to watch from there will be chapter 5.2, starting from 5.2, 5.3, 5.4, 5.5. Okay, I will write it later on. Okay, I will write it later on, but during this weekend, especially try to watch there. Okay, so that way, then I can save some time and your time too in proving something you can watch online. Yeah, the formulas. Okay, now let's come back here to our notes. Now let's do even more complicated. Nah, not that much complicated. No, not that much complicated. Just a bit more. Just a bit more. Let's say number 34. Okay, 2 cosine squared x plus sine x is equal to 1. Okay, so far we only solved an equation that involves only one function, only sine, only tangent, only cosine, right? Okay. But this equation here has two trig functions, cosine squared and sine. So Thomas, what do I do? Okay, here's the thing. Then we need to start thinking, is there any formula that can change sine to cosine or cosine squared to sine in terms of sine? And we remember, oh yeah, that's right, this guy here. I can change that into, in terms of sine, that's 2 times what?
1 minus cosine squared, or 1 minus sine squared.
1 minus sine squared, that's right, 1 minus sine squared. Okay, so let me distribute that. Rearrange. And then I set one side equals to 0 right away. Okay, and then I divide by negative or multiply by -1. Basically, I change the sign, plus minus. Now, then how do I proceed from here? Now, notice that I need to have sine equals something, cosine equals something, tangent equals something, right? Now, how about this guy then? Well, this form a quadratic-like equation. Don't forget, we learned that long time ago. I think it's either in chapter 2 or chapter 3. Very likely chapter 2. Right? Solving an equation. Okay, how about solving quadratic equation? Now, this is actually a quadratic equation, but instead of using x, we use sine x. Okay, so you still have to remember that one though. Okay, if you have a hard time to break it up, then you use substitution if you like. U equals to sine x, so you get 2u squared minus u minus 1 equals 0, and then you factor it from there. Okay, or if you want to attack that right away, which I prefer, that will be better. Okay, that will be great. Yeah. So if you see the, oh, you know what, this is quadratic like equation, then you factor it. Yes, somebody have a question?
Yeah, when you bring the 1 to the other side, isn't it negative 1? Or
2 minus
need
1.
something?
2 minus 1.
Oh, okay, got it.
Yeah. And then that will be minus 1 here. Oops. That will be minus 1 here and then plus 1 here. So I get sine x equals to negative 1/2. Sine x equals to 1. Right? Okay, and then you can solve it yourself from there. You don't need me for this. Okay, what we learn here is first, what happens if we deal with two different functions? Then one way to do it is asking yourself, can I change one function in terms of the other one? Okay, and then if I get quadratic, then treat that as a quadratic. Those are the two new questions, two new variations that we learn here. Okay, now implicitly, you still need to know how to factor them. Okay, implicitly you still need to know how to factor. Let me ask you to do, you know what, let me ask you to finish this one, finish this. And then on the top of that, I would like you to do number 36. Number 36. They already factor it for you, so that's really nice of them. Okay, so that's cosine of 2x plus times secant of 2x plus 2 equals to 0. Okay, so that one is 1, 2, 3, 4, maybe 5 minutes from now. Okay, let's work this out. So this is x equals to pi over 6 plus 2 pi n. X equals to 5 pi over 6 plus 2 pi n. And for sine x equals to 1, it will be pi over 2. Plus 2 pi n. Okay. So far we are fine. Now, how about number 36? They already factor it for us. Okay, but here we need to be a bit careful. Okay, where do we need to be careful, Thomas? Okay, then cosine 2x equals to 0, or secant 2x equals to negative 2. Cosine x equals to, cosine 2x equals to 0 means 2x equals to negative 1.
Wait, Thomas, back to 34, isn't sine x of negative 1/2 at 7 pi over 6 and 11
Oh yeah,
pi over
that's
6?
yeah, it's negative 1/2. Thank you.
Yes, that's
So it
because
should be quadrant 3 and quadrant 4.
4. Yes.
Thank you. I saw that as a positive earlier. My bad. So that will be 6 here and 11 pi over 6. Is it okay now?
Yeah, that's what I got.
Okay.
Yes.
Thank you. Now cosine equals to 0 at pi over 2 and 3 pi over 2. Right? So you can write it this way. So there are two branches, but if you think about it, you can condense that though. you can condense that to be 2x equals to pi over 2 plus pi n. Is it right? Okay, then I divide by 2. So you see this 2 here condensed. Okay, so x equals to pi over 4 plus pi over 2n. For the other branch, secant 2x is negative 2, so cosine 2x is negative 1/2. So 2x is, that's 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. Then I divide by 2, I get x equals to pi over 3 plus pi n, and then 2 pi over 3 plus pi n. Now, I need to be a bit careful here. What to be careful? Notice that secant, the domain of secant is not all real numbers. So I need to be aware that to avoid those value of secants that is not in its domain. Okay, and secant 2x is undefined when cosine 2x is 0. Okay, so let me put a note. Secant 2x is undefined when cosine 2x equals to 0. Okay, so whatever the answer we have here, it is not in the domain of the equation. Right? You see what I mean? That's why then I have to cross it out. Okay, so the solution is only x equals to pi over 3 plus pi n, and x equals to 2 pi over 3 plus pi n. The branch from cosine 2x equals to 0 doesn't work. Okay, because it will make the equation of the original equation becomes undefined. Okay. Yeah, basically we need to check against the domain of the equation at the end. Now that's what happened if we have the mixture though. If we have the mixture, sine, cosine were fine. The one we have in number 34, sine, cosine we were fine. Why? Because the domain for sine and cosine actually all real numbers. There's no asymptotes, right? Okay, but once we deal with secant, cosecant, then we need to be a bit more careful. Okay? Yeah, we need to be more be careful. Now, let me do question number number 48. Number 48. Find solution in that first interval from 0 to 2 pi for, did I say number 48? I hope I can change it to number 52. Let me change it to number 52. Number 52. And number 52, I have secant squared x times cosine x equals to cosine x. This is not a good question, actually. Yeah, this is not a good question, but I do it anyway. That's fine. Yeah, I do it anyway. Okay. What you don't want to do, don't do this. Maybe I mark it. Don't do this. Do what, Thomas? Do not divide by cosine x. Divide by cosine. then you get secant squared x equals to 1. Now, do not do that. Okay, do not do that. Okay. Now, what's wrong with that, Thomas? What's wrong with that is that we are not supposed to divide by an expression that is possibly 0. Let me say it again. When we solve an equation, we are not supposed to divide by an expression that is possibly 0. Okay? We may miss some solution that way. Okay? So for example, how do you solve this x squared equals to x? If the way you solve that is by dividing by x, then you really need to drop the class. Okay, why? Well, x squared equals to x is a quadratic equation, right? So we expect to get 2 solutions. Don't you think so? Now, when you divide by x, when you divide by x, you only have 1 solution, x equals to 1. So where's the other solution? Now that solution disappear, you won't be able to see it because when you divide by x, okay, what happens if x equals to 0, right? And you see that actually in the original equation here, x equals to 0 is an obvious solution, right? X equals to 0 is a more obvious solution compared to x equals to 1. But you will miss it because you divide by x, which possibly 0. Okay, so that's the mistake you make if you solve that quadratic equation that way. Now, the thing is, if you do the same thing here, you divide by cosine x, then you may get only 1 or 2 solutions, while there could be actually more than that. Okay, so no, this is not the right way to do it. This is not the right way to do it. Okay, don't do this. Do not divide every time you solve an equation, not only for trigonometry though. In general, when you solve an equation, okay, never divide by an expression that's possibly 0. Okay, so how should I solve this, Thomas? By factoring. So secant squared x cosine x minus cosine x equals to 0. And then factor the cosine x. Like that. Okay. So we have 2 branches, cosine x equals to 0 and secant squared x equals to 1. Now, of course, at this point, then I can cancel this out. Okay, I can cancel cosine x equals to 0 out, whatever the branch there. Okay, the reason is if cosine x equals to 0, then secant x is undefined when cosine x equals to 0. That's why I cancel it out. Okay, but the reason I cancel it is because I have secant in my original equation. That's why I cancel it. Okay, but dividing by cosine x earlier is not a correct step. Okay, dividing by cosine x is not a correct step. Now let me go on from here. So secant squared x equals to 1. So secant x equals to plus minus 1. So cosine x, the reciprocal will also be plus minus 1. Cosine x equals to 1 at at 0 plus 2 pi n. Cosine x equals to negative 1 at pi plus 2 pi n. Now, however, I need the solution in the first interval, the first period. So that's the general solution I get earlier. So x equals to 0, x equals 5. Okay, now that's the solution in the first interval. Number 56. Number 56. No, I'm sorry, number 54. Number 54. We have secant beta cosecant theta equals to 2 cosecant theta. Again, do not divide by cosecant theta. No, don't do that. Unless you are sure that cosecant theta cannot be 0. Right? Unless you are sure that cosecant theta cannot be 0. Which we know is true because the range for cosecant is not including 0. Okay, but just be careful that we do not divide by an expression that may be 0. Let me divide by cosecant theta. Okay, the reason it is okay, cosecant theta cannot be 0. Or another way to say that the range of cosecant theta, okay, does not include 0. So yes, we can do that if we can provide me the reason. So secant theta equals 2. Then from there you go on further. Okay, I hope you can contrast number 54 and number 52. Number 52, do not divide by cosine x because cosine x possibly 0. Why, Thomas? Now I can divide by cosecant theta. Well, because cosecant theta can never be 0. Okay. Now, furthermore, the following question is considered tougher one. Number 56, sine theta minus cosine theta equals to 0. That's way too easy. Number 60. My bad. Number 60. Cosine theta minus sine theta equals to 1. That number 56, the one I wrote earlier, I cancel it because it's actually an easy question. Sine x minus cosine x equals to 0. Oh, how do I do that, Thomas? Well, sine x equals to cosine x, right? Okay, under what situation sine x equals to cosine x? In my opinion, the best way to do it is actually look at the tangent. Tangent x equals to 1. So what I did here is I divide by cosine x. So see, Thomas, you divide by cosine x. Well, but cosine x cannot be 0 though. Cosine x cannot be 0 because if it were 0, it's not a solution. Okay? Because let me write it properly. Cosine x equals 0 is not a solution. Okay, so I go on from there, then x equals to pi over 4 plus pi n. So x is pi over 4 when n equals to 0, and x equals to 5 pi over 4 when n equals to 1. Now, a better solution, if I don't want to get into trouble for forgetting to give him the reason why am I allowed to divide by cosine x, the better solution is by squaring both sides and solve it from there. Let's say I make it like this. So 2 sine squared x equals to 1. So sine squared x equals to 1/2, and so on and so forth. But even this way of doing it has a problem. Notice that here, notice in this step here, we square both sides. Right? Okay, now because of that reason, because we square both sides, then whatever answer we get, if there's any step in between of you solving equation, if there's any step in between that you square both sides, then you need to check your solution. Check each solution. Okay. Let me show you further. So suppose I try to solve this in the equation here. I will get sine x equals to 1 over radical 2 and sine x equals to negative 1 over radical 2. So either x equals to pi over 4 or x equals to 5 pi over 4 or x equals to 3 pi over 4. Actually, this is 7 pi. No, that's a sine. So this is 3 here. This is 5 pi over 4. X equals to 7 pi over 4. Okay. Now, then I check when x equals to pi over 4, is it true that sine pi over 4 minus cosine pi over 4 equals to 0? That's radical 2 over 2 minus radical 2 over 2, that's equals to 0. That's a check. When x equals to 3 pi over 4, sine 3 pi over 4 minus cosine 3 pi over 4, is it equals to 0? I get this is radical 2 over 2, but cosine in quadrant 2 is negative. So I get radical 2, which is not equals to 0. Okay, so x equals to 3 pi over 2 is not a solution. So you check further, then you conclude x equals to pi over 4 or x equals to, actually I don't use the whole, and x equals to 5 pi over. Is it 5 pi? Okay, so if this in between you square both sides, then you need to check whatever solutions you have. That's not only for this case, that's for every time you solve any equation. Every time when you solve any equation, you square both sides, then you need to check whatever solutions you have. Now, what's so special about number 60? Why I kind of rush into trying to solve this number 60? Because this is the type of question in trigonometry class, in solving equation, that actually has 3 significantly different methods to solve. And I plan to show you all 3. For now, I can only show you 2. Okay, there are only 2 ways that I can present to you right now. But hopefully next week, I hope that's on Monday, then I can show you the other solution, the other method. Okay, the other method is actually feasible once we're done with 6.3. We need to do 6.3 first to learn the third method. Okay, now, what are those 2 methods? The first method is isolating. So this is method 1. Isolate one of the sine or cosine. In this case, let me isolate the cosine. And then I will square both sides. Okay, and then I square both sides. Notice that because I square both sides, then whatever answer I have later on, I need to check against the original equation. Against the original one. Then I will get, let me change everything into sine here. So the 1 cancels, so I get 0 equals to 2 sine squared theta plus 2 sine theta. Divide by 2 and factor the sine, so I have sine theta times sine theta plus 1. Okay, let me put the 2 here to make you happy before anybody asks me that question. So basically you will see sine theta equals to 0 or sine theta equals to -1, right? Sine theta equals to 0 when theta is pi n. It's from 0 to 2 pi. Let me just write it down. 0 or pi. Sine theta equals to -1 when theta is 3 pi over 2. Now I need to check. Okay. Now, what's the question again? Cosine. So for theta equals to 0, cosine 0 minus sine 0, is it equals to 1? 1 minus 0, that's equals to 1. That's a check. How about when theta equals to pi? Cosine pi minus sine pi, is it equals to 1? -1 minus 0, that's not equals to 1. So pi is not a solution. How about when theta equals to 3 pi over 2? So cosine 3 pi over 2 minus sine 3 pi over 2, is it equals to 1? 0 minus -1, that's equals to 1. So the solution are theta equals to 0, theta equals to 3 pi over 2. Okay, so the trouble here is you need to check the solution, because somewhere in between we square both sides. Now, I will show you the second method after the break. But between now and then, I want you to use the same method here to solve number 62. Number 62, square root of 3 sine t plus cosine t equals to 1. Let's have the sine t on one side equals to 1 minus cosine t, and then square both sides. Okay, now you solve this. After you solve that, you check. Okay, that should take you, let's say, around 5 minutes together with our 10 minutes break. We come back at 11. Let's come back at 11:10. I will change this to cosine on one side. So 3 times 1 minus cosine squared t. This is 1 minus 2 cosine t plus cosine squared t. And then 3 minus 3 cosine squared t equals to 1 minus cosine t plus cosine squared t. Set one side equals 0, 4 cosine squared t minus 2 cosine t minus 2. I will divide by 2. And then factor. Cosine t equals to -1/2. Cosine t equals to 1. t equals to 0 for this one, and t equals to 2 pi over 3 and 4 pi over 3. Now again, from there we check. So t equals to 0 first. So square root of 2 is inside. Square root of 3. Square root of 3 sine t plus cosine t equals to 1 of 0. 0 here, 0 here. So 0 plus 1 equals to 1. That's true when t equals to 2 pi over 3. Square root of 3 times sine 2 pi over 3 plus cosine 2 pi over 3 is it equals to 1. This is square root of 3 times square root of 3 over 2 minus 1 half. So this is 3 half minus 1 half. That's equals to 1. So that's one also check. How about t equals to 4 pi over 3 sine 4 over 3 plus cosine 4 pi over 3 is equal to 1, which is square root of 3 times negative square root of 3 2 minus 1 half is equal to 1. I don't think so, huh? So this is negative 3 half minus 1 half. That's not equal to 1. That's negative 2 actually. Okay, so then I summarize. So t equals to 0, t equals to 2 pi over. Okay, now method number two uses unit circle approach. And I don't think you see this method in your textbook. Okay, not at all. You don't see this method in your textbook at all. Okay, let me go back to number 60? Number 60, cosine theta minus sine theta equals to 1. Okay, so let me go back to number 60. Cosine theta minus sine theta equals to 1. Now, what is unit circle approach? Now, if you remember, our unit circle approach has the following situation here. We have learned that if you pick any point on the unit circle, call that x comma y, as long as it is unit circle though, then that coordinate x comma y must be equal to cosine theta sine theta, where the theta is the angle in standard position, which is basically the answer we want. Okay, so what I will do is I will replace cosine theta by x. So from that equation, I will replace cosine theta by x and sine theta by y equals to 1. Okay, now of course then the x and y must also satisfy the unit circle equation. Okay, so what I will do basically solve that system of equation. Okay, I will solve that system of equation. Now, so from the first equation, I get x equals to 1 plus y. Okay, now then I plug that into equation 2. Okay, so 1 plus y being squared plus y squared equals to 1. So 2y squared plus 2y equals to 0. So factor the 2y out. Okay, so either y equals to 0 or y equals to -1. Now then, I plug that into equation 1 for each branch. If y equals to 0, the x is 1. When y is -1, the x is 0. Okay, now then you look back into the unit circle. Then we look back into the unit circle. Okay, into the unit circle. The first coordinate 1, 0 is here, right? That's 1, 0. So what's the angle? Theta equals to 0. Okay, and the other one is 0, -1. It's here. The theta equals to 3 pi over 2. Now, okay, now the thing is then we are done. We don't need to check the solution. We are done. And that's the solution we have earlier. Right? So theta equals to 0, theta equals to 3 pi over 2. Okay. Now, how about the last question, Thomas, number 62? How about the last question, number 62? So, again, I use method 2 for number 62. Square root of 3 sine t plus cosine t equals to 1. So we say let xy equals to sine t, cosine t sine t on a unit circle, the unit circle. So we get square root of 3 y plus x equals to 1. Of course, keep in mind the restriction, it has to be on the unit circle. Okay, so I get square root of 3 of y equals to 1 minus x. Then I plug into the second equation. Okay, actually, let me solve for x instead. So x equals to 1 minus square root of 3 of y. So this will be 1 minus square root of 3 of y squared plus y squared equals to 1. 1 minus 2 square root of 3 of y plus 3y squared plus y squared equals to 1. Cancel the 1. So 4y squared minus 2 square root of 3y equals to 0. Factor the y. Actually, factor the 2y. So either y equals to 0 or no more y. Either y equals to 0 or y equals to radical 3 over 2. So y equals to 0 implies x equals to, we use this here. Okay, so x equals to 1. Or if y equals to radical 3 over 2, the x will be 1 minus radical 3 times radical 3 over 2. That's 1 minus 3 half. That's negative 1 half. So the coordinates 1, comma 0 implies the theta is 0. Okay. Now the coordinate negative 1 half radical 3 over 2 implies the theta to be 2 pi over 3. Now notice that I don't need to check. Okay, I get the answer. Actually, not theta, it's t. Okay. There's a trade-off though. In our method 1, I square both sides, but I have to check. Okay. In method 2, I actually square both sides, but I plug that into the second equation. So implicitly, my second equation checks the square that we get from the first equation. Okay, that's what actually happened there. Now, this second technique here this second method is not quite well known, but that's actually useful, especially when you get an ugly number. Okay, not in this class. In this class, I try to use nice numbers. But when we have ugly numbers, let's say if somebody asks this question, okay, then a square root of 3 cosine theta minus, let's say, square root of 2 sine theta equals to 0.7. Then how will you do this? I think, in my opinion, it's better for us to use that unit circle approach. So you basically solve this. Okay, so later on you get the coordinate x, y. Okay, and then take a look on the unit circle. Let's say it's located here. Okay, and then you do tangent inverse. So tangent theta equals to y over x. So theta equals to tangent inverse of whatever y and x you have. Of course, adjust with the quadrant. Okay, but it's a lot faster to solve it using this unit circle approach compared to the first method I showed you. Okay, that's if the situation is a lot more random number. Okay, now the thing is though, if you look at my old tests, you will always see I use method number 1 to solve this. Okay, I never use method number 2 in my solution. Okay, yeah, even in my trigonometry class, I show the method number 1 or method number 3, which I plan to show you on Monday. Okay, but I never show method number 2. I always do this method number 2 only on as an additional, like to enrich you. Okay, now that's for 6.2b. Suggested homework from there. I somehow think I already asked you to do some, but let me ask you to do more. Suggested homework from 6.2, number 1 to number 69. Just do every other odd. Okay, and then if you have more time, do more, especially on the later questions, on the more complicated one. Okay, especially on the more complicated one. But you have a weekend, right? So after you do this 6.2, I would like you to, don't forget to watch the lecture video from my Math 241. Let me write it here. I want you to watch Math 241 video on chapter 5.2 to 5.4 or 5 on YouTube. My YouTube channel. Okay, that way then we have much less proofing that I need to do because you watch it there. Now, what is 6.3? 6.3 is on sum and difference of angles formula. Now we have had some identities that I taught you in the past. The first identity, basic identity 1, is on ratio and reciprocal. Ratio and reciprocal. Basic identity 2 is on Pythagorean identity. And then basic identity 3 is on co-function formulas, co-function identities. And basic identity 4 is on negative angles. Now look at your notes again. What are those? Okay, now those are the basic ones. Now, this sum and difference of angles formula, I put that in group 1. I call that group 1. And I need you to memorize this, okay? The proof you can see the proof in my lecture video. And I strongly suggest you to actually watch that video, especially the proof, because it really improve your perception on how those formulas related. Okay, now I will prove the first one later on. Cosine A plus B equals to cosine A cosine B minus sine A sine B. Okay, I will prove only that one. The rest I need you to memorize, but I will not prove them anymore. Cosine A cosine B plus sine A sine B. If possible, memorize it in this order, because when I prove it in this order. Cos cos, sine sine, tangent tangent. A plus B, A minus B. This is sine A cosine B plus cosine A sine B. This is sine A cosine B minus cosine A sine B. The difference between you and my pre-calculus class at OSLA College is I can tell them that they have to memorize this formula right away, and I don't give them any proof. I just give them the video from my trigonometry class. Okay, and I didn't require them to watch that video, even though I still require them to memorize this. But Thomas, this class is basically quote-unquote open book for us. Yes, I know. So do I really need to memorize this? If I were you, I will. Why? Because the reason you won't be able to pass this class at this point, you know, if you are doing fine right now and later on you are not passing, It's very likely because you don't memorize this part. Okay, yeah. It's not really about the formula which you can see from the book. It's really about can you do it backward later on. Okay, yeah. But with the time I have, let me prove the first one. Okay, I will prove the first one only. And then from there, I will use these formulas, okay, to do some problems. Okay, so prove that group 1, the first formula, which is cosine A plus B equals to cosine A cosine B minus sine A sine B. Now, the way I do the proofing, I think is actually, I proved the first one. If you watch my lecture video from that my trigonometry class, you will see that I proved 1 and then using 1 to prove 2, and then using 2 to prove 3, and then using 3 to prove 4, and then using 1 and 2 and 3 and 4 to prove 5 and 6. Okay, yeah, but I will just do the first proof here, and then I will just show you how to apply this. The application is actually quite far-reaching though. Okay, now here's the proof. Here's the proof. I will start from a unit circle. I will start from a unit circle. Let me make it a bit bigger. And then, okay. Suppose I have two angles. One angle in quadrant 1. Call this angle A. And because this is a unit circle, then this will be cosine A sine A, right? That's the coordinate. And suppose I have another angle in quadrant -1. Call this angle -B. So that one's supposed to be sine A here. So if this is angle -B, then the coordinate will be cosine -B, comma sine -B. Is it right? Okay, which we know from the past that cosine negative is cosine positive and sine negative is negative sine. Okay, so far so good. That's the starting point. Okay, so you see, what is the angle between these two sides, the blue sides and the red sides? What is the total angle in between here? What is the total angle? The total angle will be A plus B. That would be A plus B. That's the angle, right? Okay, but we worry about that later. We worry about that later. Now, what I will do next is to find the distance from between these two coordinates here. I want to find the distance. Call that D. Okay, using distance formula, so D squared equals to cosine A minus cosine B squared plus x1 minus x2 squared, right? Okay, and then sine A minus negative sine B squared. I'm supposed to put square root, but I d square it. Okay, I d square it. That way I don't need to deal with the square root all the time. And then I will FOIL this and FOIL that. That's the extension of the first part, the first foil, and then plus the extension of the second foil. Which then, if I simplify, notice that this gives me 1, right? And this gives me another 1. So d squared now becomes 2 minus 2 cosine A cosine B plus 2 sine A sine B. Okay, that's the d squared. Okay, let me leave it for like that for now. Okay, what I will do next is I will take this diagram here, this picture here, and I will rotate it. Okay, and then I will rotate it. Unfortunately, I don't think I have. Oh, yeah, I want to rotate it, but on my words here, I cannot. On my notes here, I cannot rotate it in any angle. I can only rotate it 45 degrees or 90 degrees. Unfortunately, so no, that's not what I will do. Imagine the following. Imagine the following. I will rotate this graph here. I will rotate this graph here. I will rotate it in the way that, maybe I use black. I will rotate it in the way that this point here, I will rotate it in a way that that point then go to x-axis. Okay, I will rotate it such that it goes to x-axis. So of course, then this point will move by b, right? Will move by b to that side. I don't think it goes that far. It will go, let's say, this here. Okay, yeah. Let me redraw it. Let me redraw it. So let's go down. Go back to that unit circle. Okay. Then my side B later on will be here. My side B will be here. And then my side A earlier will be here. Okay, so now this point, well, the angle in between now will be, A plus B, right? Now you can see that A plus B better. Okay, this was my side B earlier. The coordinate apparently is 1, 0. That one is easy. Okay, but how about the coordinate here? The coordinate here, as we know, that would be cosine of A plus B, comma, sine of A plus B. Okay, so with the rotation I make earlier. But also at the same time, because the angle is the same, right? Then we expect the distance here should be the same as the distance d, right? The distance d must be the same. Okay, the d squared, the same d squared that we have up there, must be the same. So let me deal with the x first. That will be cosine A plus B minus 1 squared plus the y sine A plus B minus 0 squared. Okay, so difference of x being squared plus difference of y being squared. Now I will FOIL them. That will be cosine squared of A plus B minus 2 times cosine A plus B plus 1. Okay, that's for the yellow. Plus the blue one, that's basically sine squared. When you subtract by 0, nothing changed. Okay, so sine squared A plus B. But again, like before, this guy here will become 1. Together with this one, I get b squared equals to 2 minus 2 cosine of A plus B. Okay, now I combine these two, but d squared equals to d squared. Okay, so 2 minus 2 cosine of A plus B, that's what I have here. That's what I have here. Okay, should be equals to what I have here. Let me last week, I don't want to rewrite it lazy. Should be equal to that one. Right? Now then the 2 cancels. Let me divide by negative 2. So if I divide by negative 2, whatever left over there, if I divide by negative 2, I will get cosine A plus B equals to cosine A cosine B minus sine A sine B. That's the end of our proof. Okay, so the main idea is actually the following. If you take a look here, the main idea is you observe this picture, compute the D. Observe this picture, which is the rotation of earlier picture, and then compute the D. Now those D's has to be the same, but in between, once we have a unit circle, we get these coordinates here. That's actually one of the key steps, and that's actually one of the reason I prepare you way in advance about that unit circle approach. Okay, our textbook used that unit circle approach. Okay, but our textbook didn't really take the full benefit of that. Okay, our textbook actually proved cosine of difference using this similar technique. Okay, but they use cosine difference, which is, in my opinion, harder to do. I think my method here, which of course I didn't find it myself. Okay, I saw it in another book too. I don't want to take credit for this. In my opinion, it's easier to understand, easier to picture, easier to visualize. Okay, now, so my next assumption is you already memorized this formula. Okay, I know you don't yet, but in the next 10 minutes, we will do problems with the assumption that you already have that formula. So how do I use that formula? For example, suppose I want to find the exact value of part A. Let's say cosine 105 degrees, which is important too. Then we see that cosine 105 degrees as cosine 60 degrees plus 45 degrees, which according to our formula 1, you don't need to write that down. You don't need to write this down. You don't need to write this down. It's fine. I just want to show there which formula I refer to. That's equals to cosine 60 degrees times cosine 45 degrees minus sine 60 degrees sine 45 degrees. That's 1/2 times radical 2 over 2 minus radical 3 over 2 times radical 2 over radical 2 over 4 minus radical 6 over 4, which, as we expect, it's negative. Okay. Now, how about, for example, part B, let's say, what is sine pi over 12? Pi over 12, that's not a special angle, but we still can find the exact value, because I realized that sine pi over 12 is 4 pi over 12 minus 3 pi over 12. Okay, which is sine pi over 3 minus pi over 4. Okay, then I use formula 1/4. Which you don't need to write down, but if you do, you're fine. That's sine pi over 3 times cosine pi over 4 minus cosine pi over 3 sine pi over 4. That's radical 3 over 2 times radical 2 over 2 minus 1/2 times radical 2 over 2, which I get radical 6 over 4 minus 2 over 4. Put them together, radical 6 minus radical 2 over 4. I can also ask you this question, for example, graph y equals to, let's say, sine, maybe I use sine 3x cosine 40 degrees plus cosine 3x sine 40 degrees. And then you say, oh, you know what? According to formula 1,3 above, that is actually y equals to, that's actually y equals to sine of 3x plus 40 degrees, right? Which we have learned last time, or I don't even know when. We have learned that, well, the center is 0, the amplitude is 1, the period is 2 pi over 3, and the phase shift is, let me factor the 3 out, that's sine of 3 times x plus 40 over 3 degrees. So the phase shift is negative 40 degrees over 3. Now then, if you remember our 2 by 4 table, right? The center is 0, the maximum is 1, minimum is -1.
If the period's in 2 pi over 3, wouldn't you just convert the phase shift into radian?
Or let's actually, you are right. Actually, the period will be, I prefer to make it into degrees instead. What do you think? Right? Over 3, that's 120 degrees. Thank you.
Okay.
Thank you.
Yeah, that works.
So that will be, the phase shift is negative 40 degrees over 3 plus 360. So this will be 320 degrees over 3. Okay, and then add 280 divided by 4, that's 140. I'm sorry, 280 divided by 2, that's 140 degrees over 3. And the graph is sine, so the graph is sine, so it looks like this here, 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 here. You remember this procedure, right? We did that last time, even in your test. Okay. So the thing is, like, without you memorizing that formula backward, if you don't memorize that formula, you won't be able to do it backward. That's what I do here, though. You have to memorize that formula and do it backward. Now, once you condense that, then you get this graph. Okay. Now the last one is number 24. Number 24. They give us here that alpha and beta is acute angle. So alpha and beta are in quadrant 1. Okay, such that cosecant alpha is 13 over 12. And cotangent beta is 4 over 3. Now you need to anticipate what happens if my alpha or my beta are not in quadrant 1. But the key is once they are in quadrant 1, if they are not in quadrant 1, look at the reference angle. Okay, if they are not in quadrant 1, look at the reference angle. Look at the reference angle first. Now, so here I draw the right triangle to approach that. So suppose this is alpha, cosecant. So cosecant alpha is 13 over 12. So this is 13, this is 12. And then by Pythagorean theorem, this is 5. If I have beta, cotangent, so this is 4, this is 3, this is 5. And the question A there, find sine alpha plus beta. Sine alpha plus beta is sine alpha cosine beta plus cosine alpha cosine beta. Then you look at the triangle. Okay. Now again, if the alpha is not in quadrant 1, if alpha is not in quadrant 1, then you need to adjust the plus minus sign. Okay, you need to adjust the plus minus sign. Now sine alpha will be 12 over 13. Cosine beta is 4 over 5. They are all in quadrant 1, so we are safe to see that all of them positive here. Cosine alpha is 5 over 13, and sine beta is 3 over 5. I get 48 over 65 plus 15 over 65. That's 63 over 65. That's the exact value. Now how about tangent? How about tangent alpha plus beta? Tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Okay. Tangent alpha is 12 over 5. Tangent beta is 3 over 4. Big over 1 minus 12 over 5. 3 over 4. Now I will multiply the top and the bottom by the LCD. Multiply by 20 over 20. Then I will get 48 plus 15 over 20 minus 36. That gives me 63 over negative 16. Okay. Now, part C, the follow-up question. That alpha plus beta is in which quadrant? The way we look at that is the sine is positive, the tangent is negative. So the angle is sine alpha plus beta is positive, sine of the angle is positive, yet the tangent of the same angle is negative. So which quadrant is that angle supposed to be? It's in
2.
quadrant 2, that's right. Okay. Now, I think on Monday I will continue a very little bit more from here, maybe just another 10 minutes, 10, maybe 20 minutes at most. But you can do most of the problems already here. You can try to do all the problems, by the way. Okay. Suggested homework from 6.3 will be number 5, number 7, number 11, all the way to number 27. Okay, that will be nice if you can do number 29 to number 43. Okay, just do every other odd there. Just do every other odd. You don't need to memorize them, but that's basically applying the formula. Okay, and then for the proofing, number 41 to number 49. Okay, don't forget to watch the lecture video I told you earlier. Okay, where's that? I stayed up here. Yeah, I set it up here. Okay, watch the lecture video I have on YouTube. And I think that's what I want to give. Oh, what is the suggested homework for 6.2? Let's see 6.2. The suggested homework for 6.2 is number 1 to 69, every other odd. Let me go back to 6. In case that you have not written it down, that's for 613 suggested homework.